This is exercise 4.5, question 10. Now we have a triangle here. It's a right angle triangle. So we have triangle ABC with a right angle here at B. We know that because it's in the diagram, but we're also told that AB is perpendicular to BC. We're also told that D is a point on AC. So here's AC, and D is a point on AC just here, such that AD, the length AD, is equal to DB. Now the first part of this question, we have to prove that triangle BCD is isosceles. And to do that, we're wanting to show that two of the angles in this triangle are equal. Okay, what we'll do, we'll start with some of the information that we've been given. And we've been given that AD equals DB. So this is telling us that triangle ADB is isosceles. And if AD equals DB, then we have base angles of isosceles triangle. So this angle in here, which is angle BAD, would be equal to angle BDA. So we're going to let one of those angles equal alpha. So let's let angle BAD equal alpha. So this angle here, angle BAD, is equal to alpha. So you should just put that in on your diagram. Now, because we know that, again, that AD equals DB, it's an isosceles triangle, therefore angle ABD will also equal alpha, and the reason will be base angles of isosceles triangles. So we'll just write that down as well. So we've got that angle ABD is also equal to alpha, because we've got base angles of isosceles triangle, and the reason for that is that AD equals DB, and you need to say that because in the question we were never told that ADB was isosceles. So in this reasoning here, you need to give the reason why it's an isosceles triangle, and that's because you have these two equal sides, AD equals DB. Now, because in part A we have to prove that triangle BCD is isosceles, we really need to start working out some of the angle sizes in that triangle. Now, the easiest angle here to work out would be this one where we've got the right angle here. If this is alpha, if angle ABD is alpha, then this angle here would be 90 minus alpha. So angle DBC would be alpha. So we're just going to write that down. So angle DBC equals equals 90 minus alpha, because we've got basically the angle sum of a right angle, or you can write adjacent angles in a right angle, or you can say angle sum of right angle, or angle sum of right angle. Okay. So we know that that angle there is 90 minus alpha, so we really should put that into our diagram. So ideally we'd like to show that another angle is also 90 minus alpha. If we look in the big triangle now, so we've got triangle ABC, we have a right angle here, so that means this angle here at A and the angle here at C have to both add up to 90 as well, because 90 and 90 is 180. So we've got 90 here. So these two angles, the one at A and the one at C, have to add up to 90. So if this angle up here is alpha, the one at A, if it's alpha, then this angle here down at C will have to be 90 minus alpha. So we'll write that up now as well. So angle ACB equals 90 minus alpha. The reason, because of angle sum of triangle ABC. So we'll just mark in that angle as well. So therefore we can see that we have two angles in this triangle that are the same. So therefore this triangle is isosceles. So we're just going to write that down as well. So therefore we can say that angle DBC is equal to angle, you can call it DCB or ACB. I'm going to change it to DCB. That this angle down here, DBC, equals angle DCB, and they're equal because they're both equal to 90 minus alpha. So therefore we can now say that triangle BCD is isosceles because it's got two equal angles. Okay, now that's our first proof for part A. Now for part B, we have to hence prove that D is the midpoint of AC. So we have to prove that D here is the midpoint of AC. In other words, we have to show really that AD is equal to DC. At the moment, we can see that AD is equal to DB because that was given. But now, because we know that triangle BDC is isosceles and these base angles are equal, we know that side BD must equal side DC. So I'll just mark that in on the diagram with a little dash and just put a dash here, meaning that DB equals DC. So we're going to need to write that all up. So again, as we said, we know that AD equals DB, and that was given. We also know that DB equals DC because they are equal sides that are opposite the equal angles of that isosceles triangle. So DB equals DC because they equal sides lie opposite equal angles, and the equal angles are angle DBC and angle DCB. So therefore, as we can see, DB equals AD and DB equals DC, therefore AD must equal DC. So AD must equal DC. And the reason for this is that they're both equal to DB. So we can write that down as well. So therefore AD equals DC because they're both equal to DB. So if those two lengths are equal, if AD equals DC, therefore D would be the midpoint of AC. So we'll just put that in as our final line. And that is the end of the question.